Okay, so last night's homework. First question on page 485 was number 21. It's an Atwood machine again. It tells us the smaller mass is 45 kilograms, so I've called that one M1. So this will be FG1. This will be FG2. And if M1 is the smaller mass, then M2 moving down will be positive, and M1 moving down will be negative. And then, of course, our FTs are in here. So it switches this one up a little, and it tells us FT, and it wants to know what's A and what's M2. So this time you can't start on the whole system, because if you start on the whole system, you're going to have two unknowns, both A and M2. So you need to start on just M1. Okay, so on M1. And so draw your M1, and you'll have FG1 going down and FT going up. And we said this is the lighter one, so up will be positive for it. And then you do the sum of the forces will equal M1A. And so it will be FT minus FG1 will equal M1A. So this time we know our FT, we know our M1, what we don't know is A. So A will be equal to FT minus M1G over M1. So A will be equal to our 512 newtons that they gave us, minus 45 kilograms, times 9.81 meters per second squared, over 45 kilograms. And when you do this, you should get an A of 1.57 meters per second squared. Okay, so now once you have this, then you can go to the system to get your M2. Okay. So just rearrange my paper here so I don't write off the page. So then on system, so if we draw it in a straight line, this will be FG2 pulling this way, which is positive. This will be FG1 pulling back. We do the sum of the forces and it will be equal to M total A. So it will be FG2 minus FG1 equal to M1 plus M2 times A. So M2G minus M1G equal to M1A plus M2A. So just like the ones we did yesterday, you have to take all your M2s to one side and the terms without M2 to the other side. So M2G minus M2A will equal M1A plus M1G. Factor out the M2, G minus A, and then you're going to divide by that bracket. So M2 will equal M1A plus M1G divided by G minus A. So M2 equals was 45 kilograms, 1.57 meters per second squared, plus 45 kilograms, 9.81 meters per second squared, divided by 9.81 meters per second squared minus 1.5. So M2 equals, I think you get 62.12 kilograms. 62.12 kgs. Number 21 again. Number 22 is a little bit different because it says it's a 3 kilogram counterweight connected to a 4.5 kilogram window. So in lots of windows, if you were to look on the side where the window goes up at the top, you would see there's a little chain and a little pulley. And on the other side of that little pulley is the counterweight that they're talking about. So I'm going to call that MC and this MW. So the mass of the counterweight in this particular case is 3 kilograms. And the whole point of the counterweight is to make the window go up easier so that you don't have to just rely on brute strength. Okay, so the mass of the window is 4.5 kilograms. So Fg of the window is going this way. Fg of the counterweight is going this way. Now obviously, if nothing else is happening, then the window will stay down. You don't want the counterweight bigger than the window because you don't want it going up on its own. But when you go to open the window, you push up on the window. And pushing up on this side would be the same as pulling down on this one. So if we were to draw our system, this is M of the counterweight, this is M of the window. So this is Fg of the window going this way, and Fg of the counterweight. So now when you push up on the window, it's like the force is like pulling out this way. So this will be the F you're applying. And now when you do that, this side becomes positive and this negative, because this is the way it's going to move in the direction of the counterweight. So you do sum of the forces is equal to M total A, and it'll be F plus Fg of the counterweight minus Fg of the window will equal M of the counterweight plus M of the window times A. And the question wants to know how much force do you need to exert to make it accelerate at a rate. So it's telling us our A is 0.25. So we're solving for this F. So M of the counterweight plus M of the window, A, plus Fg of the window minus Fg of the counterweight. So F is equal to 3 kilograms plus 4.5 kilograms times 0.25 meters per second squared, and then plus window is 4.5 kilograms times 9.81 meters per second squared minus 3 kilograms times 9.81 meters per second squared. Okay, so 7 times 0.5 and then 1.5 minus 9.8 or times 9.81. I think you get 16.59 newtons. Alright? And that's it. That's all they wanted you to solve for number 22. Now I asked you to do number 23, but I'm going to wait to go over it because I want to hear what you think. It'd be too easy if I just tell you the answer. So please, if you haven't read 23, read 23, and we'll talk about it tomorrow. Then over on page 488, I asked you to do 24 and 25. So 24 says, a Fletcher trolley apparatus. And you might say, what the heck is that? Well, the good news is, it tells you. It's simply a block sitting on a level surface connected by a string over a pulley to a second block. Okay? So it says the 1 kilogram cart is on the level track. That's this guy. So M1 is 1 kilogram. Passing, attached by a pulley, attached by a rope over a pulley, holding a 0.5 kilogram block. So M2 is 0.5 kilograms. And neglecting friction, find the tension and the acceleration. Well, you actually have to find the acceleration first. Okay, so this will be Fg2 acting down. It's frictionless, so there's nothing pulling back. If you want to put Fg1 in, it's here. But balancing it out is Fn. So when we look at the system, the only thing acting, causing it to move, the only external force causing it to move is Fg2.